Morning, afternoon, evening, Mr. Trutna. Enjoy the show, guys. The notes, the show. All right, we're on Unit 3, Assignment number 9's notes. So what you're looking at right now, where it was talking about the trig ratios, finding a missing side and a missing angle, this right here is the notes that we went over in class. So if you were absent, you might want to pause the video and get all this information down. You're responsible for it, to have it in your notebook. Sorry you missed it. If you weren't here, we missed you, of course. But what we're going to do today is we're going to go over the expected value of a spinner portion. So we're on page 27 in your notes here, okay? So whenever we're talking about expected value and when it's of a spinner is always going to be one of those circular things like that. Okay, so you picture this as a spinner, and usually inside, or always when we're doing expected value, inside the spinner is going to be divided up into various sections. Okay, so let's go ahead and let's divide this spinner up into 3 sections. And in this particular example, all 3 sections are going to be different from one another, and the 3 sections are going to look basically like that. That section is 60 degrees. Okay, and then we have this big section here. So the smallest section, which is the 60-degree section, is worth 18 points. So picture this as a spinner. The spinner is going to go round and round and round and round. If it lands anywhere in the section here, you get 18 points. Okay. If the spinner lands anywhere in the 90-degree section, you get 12 points. And then if it lands anywhere in this large section over here, you're going to lose 24 points, okay? And what we're going to do is we're going to find the expected value of this problem. Now, the expected value, just to remind you, expected value is the average you would expect to get per one spin. Okay, so you think of expected value as the average. All right, now almost all the time the answer you get for expected value will not be one of these particular values, 12, 18, or negative 24. It's the average of what you would expect to get per spin, per one spin. And there is a definitive process on how you find expected value. Okay, and the process is this. You take the value of the section. So first of all, let's talk about the 12-point section, which obviously is worth 12 points. So you take that value that the section is, okay? So this is the process that you're going to do. You're going to take the value of the section, and then what you do is you multiply that value by the probability or the fraction that that section is of the circle. So you multiply it by or with the fraction the section is of the circle. The section is of the circle. Okay? So that's how you're going to work this out to find expected value. And you're going to do this value of the section multiplied with fraction the section is of the circle. You're going to do it 3 times. Okay? So we're going to do it, we're going to do it once more for the 18-point section. We're going to go the value, and then we're going to multiply that with whatever the fraction or the probability is of the 18-point section, and then we're going to do it again with the negative 24-point section. Okay, and then after you multiply those together, what you do is you add them up. Okay, so you're going to go each result and you add them up. And whatever it works out to, what this problem works out to, that's your expected value. Okay, so let's go. And so we know what the value is of each section. So now let's figure out the fraction the section is of the circle. Let's start with the 12 point section. So we know that the 12 point section is 90 degrees. And we know an entire circle is 360 degrees. So that means this section, the 12-point section, is 90 degrees out of 360 degrees, which simplifies down to 1/4. Okay, so it's easiest when you're doing expected value to simplify the fractions as much as possible. So the fraction this 12-point section is of the circle, it is 1/4 of the circle. We multiply those two values together. 12 times 1/4 is 12/4, and then we're going to simplify that, so that is 3. So we're going to go 3 plus, and now we're going to go over to the 18-point section. So the 18-point section is 60 degrees out of an entire circle, which is 360 degrees. So that means that when I simplify that down, that is 1/6 of the circle. Okay, so the fraction that the 18-point section is 1/6 of the circle. All right, 18 times 1/6 is 18/6s. 18 divided by 6 is 3. Okay, and then I'm going to add that to, we're going to go over to the negative 24-point section. Okay, now to figure out what fraction the negative 24-point section is of the circle, notice that the 12-point section is 90 and the 18-point section is 60. So 90 added with 60 is 150. So I've used up 150 degrees for the 12 and the 18-point section. And an entire circle is 360. So I'm going to take away 150 from 360. That's 210. So that tells me that this negative 24-point section is 210 degrees out of 360 degrees. Okay, and so I reduce that down, and that's going to tell me the fraction that the negative 24-point section is of the circle. And when I reduce that down, that reduces down to 7/12 of the circle there. Okay, so the negative 24-point section is 7/12 of the circle. When I multiply that out, negative 24 times 7 is negative 168. Over 12, and then that reduced negative 168 divided by 12 gives me negative 14. Okay, so then what I do is I add up. 3 plus 3 is 6. 6 plus negative 14 is negative 8. So your expected value of this spinner is negative 8. Okay, so what does that tell me? Well, that's telling me that on average, I would expect to lose 8 points per spin, according to this spinner here. And there we go. Expected value, you guys. So that is the notes for Unit 3, assignment number 9.